Welcome to video lecture, a course material on CE3003 prefabricated structures presented by R. Rajiv Gandhi, Assistant Professor, Department of Civil Engineering, Rohini College of Engineering and Technology. Case study of earthquake resistant structure. An earthquake is the sudden shaking of the surface of the earth caused by the passage of seismic waves through the earth crust. During the earthquake, vibration occur in all directions. Radiation from the epicenter, the sudden release of energy causes structure to vibrate and inertia forces are acting on them. Most of the earthquake are result from tectonic events, preliminary moments on the faults and remaining related to the man-made. The lack of earthquake knowledge and its incorporation in the building design and execution loads to the failure of structures. Some of the reasons behind building failures are vertical and horizontal movement and its inertia of buildings causes frequent change in building weight, use of poor quality material, massive structures, more than height of building, lesser stability. These are 9 severe earthquake has withstood by India is the last 3 decades between 1990 to 2020, and reports claim the number of casualties approx 30500. Although certain part of country are more prone to earthquake than the other, no region can be considered free from earthquakes. In the Indian scenario, minor earthquakes are reported near the subduction zone on a daily basis, whereas where in the interpolate region, few major earthquakes have been observed over the years. The performance of built environment during the past earthquake has shown its brittle nature and has created an itch among the engineers and architects to move towards seismically efficient building. Analysis of earthquake-resistant design structure against natural earthquake said that building can effectively protect against earthquake using multiple design options. Factors of earthquake designing structures where a number of opposition detail of for earthquake types can be found. About 60% of the Indian landmass is susceptible to moderate a very severe earthquake. A great earthquake in an unoccupied area may produce minimum damage when compared to a moderate earthquake. In a densely populated area, all the field survey studies conducted after a major earthquake suggested that the maximum casualties reported were caused by structural collapse. The seismic performance of a building during an earthquake depends on its shape, size, geometry, and the nature of the load path. The aim of seismic design philosophy is to ensure the safety of structural components and human life. Design philosophy states that load-bearing structural elements must suffer no damage in the cases of minor shaking, sustain repairable damage in the case of moderate shaking, and sustain severe damage without collapse under strong shaking. The main aim of a structural engineer is to prevent the structural damage that are causes due to earthquake. So the main objectives, the increase of stability of structure against inertial forces using modern techniques, to know about new and advanced method of earthquake resisting structure, to prevent deflection of structure which causes failure by using new and advanced method. The classification of the building based on the material used in the building, such as type of mortar used, concrete used in structure, reinforced wooden structures. Classification of masonry units: stone masonry, doing stonework, wood masonry, reinforced masonry, brick masonry. Then B. Classification of load bearing units of structure: reinforced wall. The wall can be made load bearable. Stresses: H-shaped girder made steel. Braces made of steel. Column: vertical reinforced concrete bars. Beams: horizontal reinforced concrete. Thank you.